So the video you're about to watch now is a cut from the video on web RTC that I did last week. So yeah, enjoy.
Now let's have a look at NAT. NAT, yeah, which is network address translation. I didn't write that in full. Let me write that here for you to see. Network address translation. There we go. Uh, yeah. So that's the full meaning. Now, what is network address translation? It's a way of translating your private IP to public IP addresses for communication. Now, someone who's not really acquainted with what public IPs or IP addresses mean might get confused here. So I'm advised to check that, but I'll talk about it a little here. So when you're when you have a PC or any device, you always have what you call a private IP address, and that private IP address is the way for you to be able to be identified on the internet. It's for your device to be identified rather. But then when you want to go on the internet, you need what you call a public address, a way in which other people can find you on the internet. So if you want to connect on Facebook, you can't connect to your private IP address, right? You need what you call a public IP address. Usually that's given to you by your internet service provider or your router, stuff like that. You get so it's just a way for your IP address is just a way for you to get pinpointed or located on the internet. People usually call it your address on the internet. Yeah. So now network address translation is just a way for your private IP address to be translated to public IP address so that people can locate you, right? So that's what network address translation is. Now let's look at the different ways this happens because they are really important to understand how WebRTC works and how you might encounter some roadblocks when working with them and probably ways to go around that. Now, there are four types of network address translation methods. You have the full cone NAT, which is also known as one-to-one NAT. You have the address restricted cone, the port restricted cone, and then the symmetric network address uh, translation. Now, so what is full cone NAT? Full cone NAT is basically saying that uh, so I have a diagram here I prepared for this so that I can try as much as possible to make it easier for you to understand, right? So don't get overwhelmed with this. Just follow along with me, and you get that. You get this rather. So you have a device A right here, right? And I want to connect with say device B over here. Now what happens is this is my private IP address. Okay, let me move this to the side a bit. Let me go full screen. Yeah, there we go. This is better. So I have my private IP and I want to connect with this device right here. So this device's public IP. Now what would happen is when I try to send data to this device, my router here will say, okay, you're about to go out there to the internet, this world where you have a lot of things, crazy stuff out there. So it's trying to protect you. So what it will do is take in your public IP address and then your public port there and translate it to a public IP address. Usually it would use its own public IP, its own IP address, yeah, and then generate a port for you. So when you generate this port, that would be your public address and public port. Now, it would using this address, it's going to send data to this particular device here. Uh, Now, this particular device then would receive it. Now, the thing with FullConnect is that once you send data to this user, right, this user can say, okay, I want to send data to you, and then just send data to your public IP address as well, and you receive it. But now, FullConnect means that anybody who also knows your IP, your public and IP address and your public port can also send data to you. Yeah, so if any other stranger sees this and say, okay, there's someone device, this is devices A public IP address and port, they can just send data to you directly. That's what full connect is. No much security on that, no restrictions. Data can be sent to you once your IP address and your port is known. So what is our address restricted code, right? Okay, let me check a bit here. Okay, So address restricted code or restricted code NAT. Now this is saying that if I want to send data from device A to device B over here, of course my IP address, private IP address, gets translated to a public IP address and port, and then I send data to this user here on this port. Now address restricted code is saying that if device B wants to send data to me, my router will check. Every network, every request to device A will go through the router, right? Because this is how I'm accessing the internet. So device A's router will check, have I connected to devices B, this current device that is trying to send something to me before? Have I sent data to that device, device before, or IP address? So it's going to check the table and say, okay, I won't send data to this device via this public address, right? And then it's going to receive your data. But if this device here tries to send data, it's going to check. So let's ignore all of this part here, right? Let's ignore this for now. So let me delete it. In fact, uh, yeah. Oh, sorry about that. Okay. So if I try to send data from this public IP here, then my router will check, have I sent data to this IP address before? No. So automatically that would be a failure. There wouldn't be any data transmission between this and this because I have not sent data to that particular port, to that particular address rather. So when it comes to port restricted CONAT, it's the same thing, except that the router would only receive connect requests from a device which data has been sent to. Okay, but it would also check the port. So basically what I'm saying is it will only receive data from devices that from a public address and public port that it has sent data to previously, right? So if I try to send data from, let's say, 19 this public address on ports, okay, let me draw an arrow here. So I try to send data back to this device A, yeah, or let me see, let me duplicate this. So if I try to send data on this same public address but on port 2000, then my router would say, okay, I've received data from this address before, but not from this port. So it's going to reject this connection, right? Because it is also port restricted. Port checks for both the address and the port. So if this even tries to send data at all, let's say it wants to send data from here to here, it will automatically be a failure because it doesn't even recognize the address in the first place. So that's not going to work as well. So that's port restricted CONAT for you. All right. I'm going to cancel that. Yeah. So now let's go into symmetric NAT. I'm going to reverse and add steps I added. Okay. Oh, I've made a lot of changes. I want to add this back here. Okay. So let me have a touch on restricted and port restricted um, CONAT again with this particular data. So if I send data to this particular IP to this device, to this public IP, and I try to send data back on a address restricted CONAT, would it work? Think about it before I say the answer. Uh, so I try to send data from here to here on address restricted CONAT. Yeah, it would work because I've sent data to this public IP address before, and the port wouldn't matter. But if I try to send data from this same IP address, right, but on a different port, let's say I want to send on ports, let's say 5000 for example, then it's not going to work because I'd never sent data to this public address and this port 5000. I only send data to, oh sorry, that's mapped to the wrong place. So I've only sent data to 12346 and not 5000. So that wouldn't work, right? Uh, Now for symmetric NAT, now difference is that between symmetric NAT and port, they are kind of similar. Yeah, symmetric NAT it wants to, it sends data just the way others sends data, but then when it wants to receive data from any of these devices, it checks, have I received data from this destination address? Have I also it's also going to check for the ports, but then it's also going to check for the public address and the public port. So if you think about this for a while, you begin to ask yourself, so what's the difference between symmetric and port restricted corners? Because if my device would also always be giving this public IP and port, difference between them is that symmetric NAT does not always use the same public port for every connection. So if I want to connect to device A, for example, device B, for example, it can connect on port 1000, yeah. But now if I want to connect to this same device on another port, yeah, this will change. So this might turn to something like, let's say, 1500, which means that if I want to send data from this device to 1100, but if and I send it on ports, let me say 12344, right? So let's say I want to send data from IP address on this port 12344. Then my router is going to check, okay, have I sent data to this public IP and this public port? Then if so, it's going to check, have I also did I send on this particular public address and on this particular port in which this router is trying to send to. If it's true, then it's going to accept the request, but which means that's successful, right? But if I try to send data to this here on this port, but to this particular IP address and this particular port, what my uh, router will check the NAT table and say, okay, have I received data from this address and port? Okay, that's true. But then remember, you send data to this public address and this public port. So the router is going to say, okay, if you are sending data to me on this, I'm expecting your IP address and your IP port to be this. So it's going to reject this connection, even though your public IP address and your public port is registered on the NAT table, which would work for restricted core NAT, right? So that's kind of the difference between restricted core NAT and symmetric NAT. The difference is basically that in symmetric NAT, you would not be using the same port for all your connections. So in the case of a device where you're sending data via different ports, you cannot send data to the same device on different ports. You have to keep sending data back on the same port. So it's kind of more secure, and that's causes some form of restriction. No pun intended. Some kind of restriction on how you send data via web RCC. It's quite secure, and that's a good thing. So now let's move on.